Guys. So let's talk about designing a solution. I've started sharpening my Java skills, so I'll be coding in Java today. The problem is design a circular queue. So a circular queue is basically a first in, first out principle. But the problem with a regular queue is that whenever the queue gets full, we cannot be, using the spaces of the first elements to store new values. Whereas in a circular queue, when as you start dequeuing, you will start uh, putting in data at the front of the queue once the queue is full, right? So for example, if I have a queue of 5 spaces, the elements are 1, 2, 3, 4, 5. Right now, if I try to put in a sixth element, the queue is full. In a regular queue, if I have consumed this element, if I'm done by using this value, I cannot add more values. But in a circular queue, if I add a sixth element, 6 will appear here, 7 will appear here, so on and so forth. So let's see how we can implement this. And it goes without saying that because it's a technical challenge, we cannot be using the built-in queue data structure. So the data holder is supposed to be a simple integer array. This is what I would go ahead with. So yeah, let's initialize it, and let's initialize a space. So all the functions that we need is, yep, so let's define a size for this queue. So there's the data equals new int and reserve memory. Let's add a field to hold in the max size, right? Then let's add a pointer that's pointing to the current size of the queue. Let's add a pointer that is pointing at the head of the queue. Let this be as 0, or let's just keep it as -1 for now. Okay, and tail index of a queue. So head index is where we are gonna read from. Tail index is where we're gonna feed the data. With each operation, we will be updating size accordingly. If we have reached max size, we will stop all enqueue operations. Whenever we dequeue an operation, we will be reducing the size that enables, so on and so forth. I think our queue should function well. All right, now enqueue function. Okay, let's go according to the sequence that's in the question. So front function gets the front item from the queue. If the queue is empty, return -1. Okay, so if the queue is not empty, that is size is greater than 0, right? Let's initialize the size to 0. Okay, if this dot size is greater than 0, if it is less than 0, we return -1. So one scenario solved. Second scenario, if the size is greater than 0, we return the element from the front of the queue, so the head index element, right? So return data this dot data this dot head index, right? This looks good. Next would be logically array gets the last item from the queue. If the queue is empty, return -1. Same. So I'm just going to copy the implementation from here. If the size is greater than 0, then we return the tail index. Correct? Yeah. Next function, according to the question, is enqueue, which accepts a value. It inserts an element into the circular queue, return true if the operation is successful. So first things I need to check does the queue have space? If this dot size is less than this dot max size, correct? If this queue has no more space, then it clearly tells me to return false, correct? Return true if the operation is successful. That is an implicit understanding that return false if it's not. So if it is a logically possible operation, where do we want to put in a new data? So we would increment the tail index by 1 int new index equals to this dot tail index plus equals to plus 1. Now if this new index is beyond the size of the array, we want to circle it back to 0. So what we are going to do is mod this value by the array's length minus 1. So what does mod operation do? You can look it up. So modulus operation is gonna make sure that the index comes back to 0 if it has reached the length, right? This might be to be modded by the length actually. We can find it out when we run the code and see the actual values inside. So now at this index, I want to feed in new data new index equals to value return true. And one last thing that we have to change is, so instead of creating a new index, let's just update the value of the existing field that we know, this dot index, correct? And yeah, size plus plus, correct? So we are putting in data right at the beginning of the queue if the queue is full. Correct. For instance, I have a queue of 3 data, all right, which currently my head pointer is here, my tail pointer is here. So this index is, let me just put the index values for ease of understanding, right? Index is 2. Now I'm trying to put in the next index, so that's 2 plus 1, 3. Mod it by the length of the data, that is 1, 2, 3 length. So 3 mod it with 3 gives me 0. So it's going to jump back here. So this dry run works for this implementation of jumping back to the position 0. Going ahead, and the next time when the tail index is at 0, when we put 0 plus 1 would be 1. When you mod 1 with 3, you're going to get 1. So the index is good. For all other values, this operation is redundant. Only when the value exceeds the size, that's when this operation would play handy. All right. Yeah. So this is a good implementation of NQ. Now let's go ahead with the DQ implementation. DQ deletes an element from the circular queue, return true if the operation is successful. So now we actually don't need to delete anything from the data because we have a pointer. So what we are going to do is we are going to simply shift the head index ahead, correct? So let the head index originally be 0, not -1. Tail index is -1 because yeah, we are incrementing the tail index and then adding a value. So the first time an NQ operation is called, we will actually add a value at 0. The first time a front operation is called, we want to read the operation, the ID at 0. First time a tail index is called, if we actually have data, automatically we would be reading a value from 0. This is the, I think, no, there are 2 more functions to be implemented. Yeah. So DQ deletes an element from the circular queue. Now this delete is supposed to happen from the head index. So if this dot size is less than this dot max size, same if condition, same else condition, right? And so now we have a valid case where you need to delete. So this dot head index equals to this dot head index plus 1 to be modded by the same thing, this dot data dot length. Or even if we use the max size variable, it's going to mean the same thing, because as you can see, it's literally the same thing. Yeah, so head index is here, and I got to reduce the size, right? So once this is done, this element is technically deleted. The next time someone tries to read an element from the front, the head index has moved. So from a user's perspective, that value is lost, correct? Boolean is empty. Is empty would be a simple return this dot size is equal to 0, right? Is full, return this dot size is equal to this dot max size. Okay, now is the best part. Let's wait for errors. Perfect. We missed a semicolon. One. Missing return statement. Why? Oh, right. I need to return a true here. See? As long as you can understand through the logic of creating everything, you don't have to worry too much about the syntax errors at the very beginning. So now that says the answer is wrong. So it's null, true, 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 false, 3, true, false. This is the one that is wrong, third from right. So a dequeue operation probably has a mistake. Let us see a dequeue operation's implementation. If size is less than max size, okay, where I have said you cannot dequeue at this point. Now let's go through the logic again. My circular queue, NQ1, NQ2, NQ3, NQ4, get the rare. So you created a queue of size 3. This fourth should be a problem. So yes, this is a problem. That's good. Then you get the value of rare. Yep. Is full, true. DQ. You should be able to DQ at this point. So there is something that is going wrong. Hey, 1 second. The size is equals to the max size. So this needs to be, oh, sorry. Yeah, see, there was a logical bug here. To DQ, I don't have to consider the max size, but I have to check if the size is bigger than 0, then I allow a DQ operation. So that's exactly what was wrong. That's a very nice example of how to debug. Perfect. Our solution is accepted here. Let's use all the example test cases that they have in the problem. Apparently they have only one. I'm going to rerun the code once. Beautiful. Let's submit this. Accepted. Hey, not bad. We can improve the code, but that's probably for another time. Have a good day.